Okay, the topic of this lesson is how we change forms. How do we go from one form of a quadratic to another? This gives us flexibility because there are certain advantages to having a quadratic in vertex form because we can see like the flip, we can see the shifts left and right and up and down and all of that. And there are advantages to having a quadratic in standard form, especially if we want to solve the quadratic equation using that quadratic formula, which we haven't done yet, but we will. And so we'd like to be able to go back and forth. This is analogous to this skill, and I know I did this in another lesson recently, where you would take a linear equation, remember standard form of a linear equation, and you would rewrite that linear equation by solving it for y. And the reason you might do that is so that you could graph it or so that you could see the slope of the line. And so you have this like algebraic skill where you can go from standard form into slope-intercept form, and then in some algebra classes you'll go from like having it in slope-intercept form to writing it back in standard form. Again, the reason for that is so that you have the flexibility to use the form of the equation that's going to work best for whatever problem you're trying to solve. So we're going to go and cover this with quadratics in two different directions. We're going to do from vertex form into standard form. This is actually the easier of the two directions to do. It does require that we review squaring binomials, so we'll spend a little time talking about that. And I'm going to do two examples and then we'll have a practice. And then I am going to show you how to go from standard form to vertex form, and I want to introduce a process to you called completing the square. So let's take a look at example 1. So this is y equals x plus 4 all squared minus 3. So this is in vertex form. There is no flip. It is not skinny or wide. Okay, so no what we call like stretch on it. It goes left 4 and down 3. So this would be really, really great for figuring out the domain and the range. Or domain is always all real numbers, so, but definitely figuring out the range because you can see where the shifts are. You know what the vertex is. It's pretty easy to sketch it in this form. It's not a bad form. If we wanted to change it to standard form, we simply carry out the algebra as shown. So remember the definition of squaring. Definition of squaring means to multiply something by itself. And so what is being squared here is the parentheses. The parentheses are what's being squared. So when I go to square this, I'm going to take what's in the parentheses and I'm going to multiply it by itself. And I'm going to bring down the minus 3. Now, somebody is saying, I know somebody's saying this. Okay, so I'm going to put this like caution. Somebody's saying to themselves, Miss Taylor, isn't this equal to x squared plus 4 squared? The answer is a resounding no. No, 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 no. Somebody take a screenshot of this so that when half the class decides to do this, it's not going to be because I said you could. No. No, no, no. All right, now I'm going to show you why that doesn't work. Because something happens when we put letters in here that suddenly students like to violate all their orders of operation. So watch this, okay? Suppose I have 1 plus 2 all squared, okay? So instead of having x plus 4, we have 1 plus 2. But it's essentially the same problem, just I'm using numbers instead of a variable. We know from order of operations that the first thing I have to do is the parenthesis. So I'm going to do 1 plus 2 is 3. And then after the parentheses comes the squaring, and 3 squared is 9. Okay? Now, what happens if you try to pull this little number where you say, oh, if I have parentheses squared, I can just square everything inside? Well, let's see. Okay, and let make sure I label this. This is correct. Okay, the answer to that problem is 9. Let's say somebody tries to do this, and they say, oh, well, that's just 1 squared plus 2 squared. Well, 1 squared is 1, and 2 squared is 4, and 1 plus 4 is 5. Okay? They cannot both be right. All right, if you're starting in the same spot and you are ending up with two different answers, they cannot both be right. One of those answers is the correct answer to have, and one of those answers is the wrong answer to have. This is the correct one because it follows order of operations. This is incorrect. Now, the point of this is that you cannot just deal with like a squaring outside the parenthesis by just squaring everything inside. Now, watch what happens though. Let's get rid of this because this is wrong. I don't want anybody to look at this, okay? What would happen if I do what I did over here? Go me. Do what I did over here and actually square the whole thing. Now, my college algebra kids will do this. It's like really weird, but okay, and we have 1 plus 2 plus 1 plus 2. So now we'll do 1 plus 2 is 3, 1 plus 2 is 3, and then 3 times 3 is 9. That actually works. So when now I wouldn't do it that way because it's a whole lot messier than doing it this way. And when you have numbers, you have the option of doing it. But when you have a letter in there, like you have to do it out this way. And so no, 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 and no again. Okay, I know I'm probably sound like an idiot, but whatever, because like about half of you are going to still try to do it anyway. No, don't. Now that we've established that, now we need to figure out how do you multiply this. So this is often described with an acronym called FOIL. I'm actually not a huge fan of the acronym FOIL because all FOIL is what I would call glorified distribution. Okay, it's just a distributive property. And you take everything in the first set of parentheses and you're going to distribute it to everything in the second set. So you start with the x, and we're going to distribute the x over these parentheses here. So x times x is x squared. X times x is x squared. Now take the x and distribute it to the 4. So x times 4 is 4x. Now you've distributed the x. Now we're going to go ahead and distribute the 4. 4 times x is 4x. And 4 times 4 is 16. Bring down the minus 3. Now, this is what FOIL stands for. FOIL stands for first, outer, inner, last. So you take the two first terms and multiply them together. That's the F. Then you take the outside, okay, the x and the 4. But notice that that's just distributing. That's all that is, first, outer. I stands for inner. Those would be the two middle ones, okay? And then L stands for last. So you do 4x and then 4 times 4. But notice that that's just distribution. You're distributing the x and then distributing the 4. So I prefer to think of it as distribution because FOIL will not work when you have more complicated things to multiply, but distribution will. Now let's combine our like terms. Remember that x squared is its own little lonely term here. Okay, it doesn't combine with anything. But I do have 4x plus 4x, which I can combine, and that will give me 8x. And then I have 16 plus negative 3, and that is 13. So make sure that you are combining your like terms. And that's the end of that. And now you have it in standard form, where you have 1x squared plus 8x plus 13. And now you know your y-intercept is 13. The vertex is -4, -3. But the y-intercept is 13. So the different forms give you different pieces of information. All right, I'm going to do a second example. Just a reminder, don't do that. No, 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 never, no. Okay. That's not the last time you're going to hear me go off on that. All right, let's do example 2. So this is f of x is equal to -1/2, and then we have x minus 2 squared plus 4. So what do we know about this? First of all, it's in vertex form. I know it is flipped over because I have a negative. I know that it is a compression, okay? It's a compression because the number is less than 1/2. I know it goes right 2. I know it goes up 4. And I know it's a quadratic because of the squaring. Math is consistent. So order of operations does not change. The very first thing you need to do here is the squaring. You need to do the exponent. This is multiplication right here. And you have to do squaring before you do multiplying. So for my next line down, I am going to do out the squaring, which means you multiply it by itself. Do not square the x and square the 2. Don't. It's wrong. Now I have a bunch of multiplication here. So you have multiplication here and you have multiplication here. And multiplication is associative and commutative, which means that you can really juggle around the multiplication and do it in any order you want. I actually think it's easier to do that foiling or that distribution first. So I'm going to bring down the negative 1/2, put my parentheses here, okay, because the negative 1/2 is multiplying everything. And I'm going to do my foiling. So x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. Bring down this positive 4. Like this guy's going to hang out until we're ready for him. Now you have a choice. Some people like to distribute the negative 1/2 through all the way. I tend not to. I tend to like to simplify what's in here first and do negative 2x minus 2x first. That's really up to you. I just don't like to tangle with the fraction a whole lot. Negative 2x minus 2x is negative 4x. And again, that plus 4 is just hanging out over here until we're ready for it. Now let's distribute. So we're going to take that negative 1/2 and distribute it through. Don't freak out. Or take a moment and freak out, and then we'll be over it. Everybody have their moment? Okay. Negative 1/2 times x squared. Don't overcomplicate that. That's just negative 1/2 x squared. Now, I'll do a little bit of scratch work over here. Negative 1/2 times negative 4. Well, remember that negative 4 could be written as negative 4 over 1. And when we multiply fractions, we multiply straight across. So negative 1 times negative 4 is positive 4. 2 times 1 is 2. And 4 divided by 2 is 2. Plus 2x. Now we're going to do negative 1/2 times positive 4. So, don't overthink this. Okay, that's positive 4 over 1. And so negative 1 times, negative 1 times 4 is negative 4 over 2, which is negative 2. And finally, we don't need these parentheses anymore, so we can bring down the plus 4. And then the only thing left to do is now finally we have some terms out here that we can deal with. We have negative 2 plus 4, which will give us... what does that? I can't look that far. Okay, wait. It gives us 2. And we're done. So now we have gone from vertex form to standard form. Pretty much it shouldn't be anything new for you. So you have done squaring binomials before from Algebra 1. It might be a little bit stale, a little bit old, but you have done it. So after you do a couple problems, you should start to feel more comfortable. You've done distribution. Okay, you might not like distributing with a fraction, but it's doable. You can also use your calculator to bail you out with some of that arithmetic if you need to, and you've certainly combined like terms. So it's not anything new, it's just a matter of making sure that you pull the right old pieces of information to use at the right time. So let's do a quick practice problem. I'm going to have you guys go from vertex form to standard form on this one. Now, this one is harder than the first one because you do have a number out front, but it's easier than the second one because the number is an integer instead of a fraction. So we will pause the video and have you guys work that out, and then we'll go over it together. Okay, now the next skill. And this is something that I don't typically require my Algebra 2 students to know, but I absolutely want you to be familiar with it. And if you're in the hunt for bonus points, so you've tripped over something in the second quarter, there are some bonus points available coming up with this process. So this is going from standard form to vertex form. and it involves a process that's called completing the square. So I'm going to put that vocab up here, okay? Involves this process, and this is going to seem like a kind of a random process. You can actually use this to solve quadratic equations. Sometimes it works really well. If you're thinking about college algebra or pre-calculus, you will need to know this process for dealing with circles and equations of circles. So I want you to think about this. I want you to think about completing, okay? Completing is going to involve like adding something to. So like if your boyfriend or your girlfriend completes you, like you add the two of you together and you're like totally one and you're completed. Squaring is the square is going to refer to a perfect square. Okay. And it's going to involve some like factoring, and we haven't really gone over factoring. You've seen it from Algebra 1, but I have no delusions about how well that probably went or how much you remember. So just bear with me on this. So here's our function. It is going to be x squared plus 6x minus 1. This is in standard form. A is 1, B is 6, C is -1. And what we want to get this in is the form with the vertex. So here's what we do, okay? In the next line down, we are going to write down the x squared plus 6. Now I am going to do plus a blank. This is the completing part. Okay, we're going to add something. We're going to add something to the x squared plus 6, and we're going to complete it by adding it. Now, we know from our rules of algebra that you cannot just arbitrarily add something into one side of an equation. You can't just add something because now they're not equal anymore. Y was equal to this thing, and if I add something in, it's no longer equal to y. So in order to keep it balanced, I'm going to have to subtract the same amount. So pretty much we're going to add something, and then we're immediately going to subtract it. And that's going to keep it balanced, because adding it and then taking it away won't change the value. Okay? Here's the process. You're going to take the b value, okay, which in this case is 6. You divide b by 2, and you're going to save that number, okay? Where can I put that? Okay. Save. Okay? You're going to save that number. It's like somebody giving you like a voucher for something and saying like, bring this coupon back for like a free ice cream cone. Okay? Like save the 3. Save the 3. It's going to go in the parentheses later. Then take the number that you get out and square it. This is the number that you are going to add and subtract. So it's actually a fairly simple process. It probably makes no sense to you whatsoever as to why we're doing this, but it works. It has to do with like factoring the quadratics when we're done with it. So whatever number you get out right here, that is the number you're going to add, and then in order to keep it balanced, you're going to subtract the same number. Now, what we do is we are going to take this and we are going to factor it. So what I'm doing right there is I just kind of grouped this together. Now, I do not think that probably you guys remember a whole lot about factoring. And if you do remember it, you probably don't like it very much, okay? You probably don't like it very much. But here's what it is. And this will probably ring a bell when I do it out. Factoring means you're going to try to split this up into like the two parentheses. When we get to this, I'll go into like excruciating, painful detail about like what the factors are and what we're trying to do. But in short, the x splits up into x times x. And then you're looking for two numbers that multiply to give you 9 and add to give you 6. Well, two numbers that multiply to 9 and add to give me 6 would be 3 and 3. Now, if you go back and you FOIL this or distribute, you get x squared plus 3x plus 3x plus 9. And 3x plus 3x is 6x. Remember that if you multiply something by itself, that's the same as squaring. So earlier, though, instead of going through this, which you can do if you really want to, okay, but you probably don't want to, I said to save the 3. The reason I said to save the 3 is because 100% of the time, the 3 is what's going to go in the parentheses, like 100% of the time. So when you take that middle number and you divide it by 2 and you get some number, like you don't even have to think about it. And then -1 minus 9 is -10. And now I have it in vertex form. So this parabola here, okay, where all I really know about it is that the y-intercept was -1. In vertex form, I can see that it goes left 3 and down 10. So the vertex would be -3, -10. And now I've changed the form of that. Now, that's called completing the square. And again, remember, completing meant to add something, and the squaring is this part here. So what you're doing is you're adding something that's going to give you that nice, what's called a perfect square. So the process for completing the square looks like this. You take b, divide b by 2, and then you square it. I don't know how we're going to be doing for time at this point, but I'm going to give you a practice problem just to see how you do. If we don't get to the practice problem, that's fine. We'll just kind of see how the timing goes. So this is y equals x squared minus 8x plus 24. See what you're able to do with it. See if you're able to drag yourself through those steps that I just did and figure out what the vertex for this particular parabola should be and change the form of it. And just see how it goes. And you never want to complete the square usually if you have another number out front here. So as long as the number that you have out front is a 1, completing the square is not too bad. It's when you have numbers other than 1, then it really, really becomes messy, which is why I don't always teach it. But see what you can do with it. Okay, so let's take a look at this. So we have y equals x squared minus 8x. And then I'm going to add something in there. I don't know what I'm adding yet. And in order to keep it balanced, I've got to subtract the exact same thing. So the process is to take your b value, which is -8, and then divide that by 2, and that gives me -4. I'm going to save that number, okay? And then we'll have -4 squared, which is 16. That's the number that's going to go in here. So we're going to add 16 and then we're going to subtract 16. Now I have this, what's called a trinomial. And this can be factored, but I don't really need to do any work with the factoring because remember this number that I saved over here, the -4, is always going to go in there. And then 24 minus 16 is 8. And so if you did that out, you would have gotten y equals x minus 4 all squared plus 8. If you were able to do that, consider it a victory for the day. If you go on in math, you will see this process again. So it's good to like encounter it and kind of go through the steps and familiarize yourself with it a little bit. So for those of you that move on, you won't be totally confused when you see it again. But for me, it's typically going to be like a bonus. So kind of you can file this away under when you're studying for your test. If you want to shoot for some bonus points, this is something you'd want to study. All right. And that's a wrap on this lesson.